Good morning, students. Welcome to the chemistry class, students. I hope everyone is very safe. Okay, take care of your health and you have completed the first exam successfully. Okay. So for this session, I am going to take the topic shape of atomic orbitals. Okay. So first I recall the previous that is the class. In the previous class we saw the quantum numbers. Okay, quantum numbers. So in quantum numbers, that is 4 quantum numbers, that is we saw. So 4 quantum numbers. One is principal quantum number, azimuthal quantum number, magnetic quantum number and the spin quantum number. Just I write the letters representation. Principal, azimuthal, magnetic, spin quantum number. So this principal quantum number talk about maximum number of electrons present in the orbit. Okay. So center, nucleus, electron is revolved around the nucleus in a circular path. It is called as orbit. Okay. So nucleus, so K shell, L shell, M shell, N shell, okay, and O shell. Okay. So each shell or orbit, how many electrons it is possible? Talk about the principal quantum number. Next, this azimuthal quantum number, talk about the subshell. Okay, subshell. So first orbit, no subshell. So second one, that is L, it contains. So first one, that is only one. Okay. So second that is the shell, that is the 2 subshell, and M, that is the third one, 3 subshell, and fourth one, 4 subshell. Okay. So this one keep it in mind. Okay. So next one, this magnetic quantum number, talk about the orientation. So this one, how much, that is the talk in, that is azimuthal subshell. Magnetic quantum number, talk about the, that is the orientation. Okay. So next one, the spin quantum number, talk about this electrons in the spins. Okay. That is it rotate, that is by itself. Okay. Not only around the nucleus itself also, that is a rotate this electron. So it is a clockwise direction as well as anti-clockwise direction. Okay, so from this topic, now that is as the question, that is 2s orbitals is given. So what about the n as well as l? That's all. So this is the question. Okay. So in 2s orbitals, what is the principal quantum number as well as azimuthal quantum number? Okay. So this number is denoted as the principal quantum number. So n equal to 2. Okay. So l equal to, that is 0. Okay. So now this is a clue. Now L value 0, 1, 2 and 3. This one for L value. Now write the orbital. Okay, S orbital, P orbital, D orbital and F orbital. So this very important concept. So keep it in mind. Okay. So now L value 0, denoted the orbital is S orbital. L value 1, denoted as the P orbital, 2 D orbital, 3 F orbital. Okay, children. So now see here another pattern. Now N value is given as well as L value also given. Okay. So here L value, that is 1. So now to find out the, that is the orbitals. Okay. So now N 5. So 5, L is equal to 1. So what about the orbital? So denoted as, that is 5p orbitals. Okay, children. So this one already saw in the previous video. Just I recall it. Okay. For this session, now we are going to study the topic shape of orbitals. So orbitals means, you know how many orbitals? S orbital, p orbital, d as well as f. So each orbital, what is the shape? Okay, so s orbital, what is the shape? Same way for remaining. Now we are going to discuss for this session. Children, now see the atomic orbital definitions. Okay, so this atomic orbitals have, that is, different ways discuss the definitions. Even now I am writing here 3 definitions. Okay, so all the definitions give the same point but in different way. Okay, so see here, orbital, that is atomic orbital, it is a 3-dimensional space. Okay, in which the probability of finding electron is maximum. Okay, so atomic orbital means it is a 3-dimensional space. So 3-dimensional space means it denoted as, that is for 3 axes, x, y and z, 3 axes. Okay, so it is a, that is the sphere shape. So now electron is revolved around this nucleus, just imagine. Okay, so here the electron is maximum. Probability, the word is very important, hereafter it is repeated. Okay, the probability means it denoted as it is random. Okay, not the particular. Okay, so electron, it is present, it must present here, it is not possible to, that is say, because this electron is wave in nature. Okay, we know that is a duality characters of electrons. Okay, electron has both particle as well as wave character. So particle means it's no problem, it is present at a particular place. So wave means it is not present in the particular, it moves. Okay, so the probability word, it denoted the electron is present here or here or here, wherever. Okay, but within the sphere it is present. Are you clear, children? So this electron also maximum amount it is present. So that is denoted as the atomic orbital. This is the one way. And another one, Schrodinger wave equation gives the energy value. So using that is the solution of Schrodinger wave equation gives the energy values, E values. So it's called as eigenvalue. And wave function corresponding to eigenvalue is called atomic orbital. This is another one way that is explained the atomic orbital definition. And simplest way, it is a region. Okay, here the highest probability finding electron in an atom is known as, that is the atomic orbital. Okay, so children, now you know very well about this atomic orbitals. Okay, in another one way, that is express the atomic orbital definition in, now center part is the nucleus. Okay, electron is revolved around this nucleus. Okay, children, electron is revolved. So now it not only that is for that is electron in spherical shape or dumbbell shape or double dumbbell shape. So different ways this electron is, that is the revolve, that is in the nucleus. So the path is known as, that is the atomic orbital. This is another one way that is express the atomic orbital definitions. Okay, so now that is discuss the shape of atomic orbitals. Now let us see the example, that is one electron species. That denoted it contain only one electron. So see the example, hydrogen. Okay, hydrogen atomic number 1. So next one, helium, He plus. Okay, normally helium atomic number Z is equal to 2. He plus means 1 electron it is lost, so Z is equal to 1. Okay, next one, lithium plus 2. Okay, so now the electron, that is 1. Lithium atomic number, that is 3. Okay, now 2 electron it is lost, so number of electron, that is 1. So hydrogen number of electron for hydrogen 1. helium plus number of electron 1, lithium plus 2, number of electron that is 1. Are you clear, children? So this is the one electron species elements. Okay. So for this one electron species, now to find the wave function. So wave function symbol psi. Okay. So now it is spherical, that is the coordinate. So it is a 3-dimensional atomic orbital. It is expressed in 3-dimensional space. Okay. So x-axis, y-axis and z-axis. Now the electron it is present here. Now to find that is the distance. Okay. So that is the distance from the nucleus and electron. So r. So first coordinate is r. Now to measure the angle. Okay. So that is theta. So theta. And next one, the second part, that is the positive sign. So this angle here it is denoted as that is pi. So r, theta and pi. So 3, that is the coordinate. Okay, equal to capital R, R. Okay, this one. Next F, theta. And next one G and pi. Are you clear, children? So now to frame one equation, wave function psi equal to RR F theta G, that is pi. So from this RR it is denoted as, that is the radial wave function. Radial wave function. Next this 2. Now to here to find out the angle. Okay, so this 2, that is F as well as G, it is denoted as, that is angular wave function. Wave function. This one for radial wave function, and next remaining 2 as the angular wave function. Children, now this wave function is called, that is denoted as, now that is we see the definition. This eigenvalue is corresponding to this wave function and it is expressed as the atomic orbital. Now see the definitions. Okay. So now to express the wave function in oneness, that is electron. For example, hydrogen, helium plus and lithium 2 plus, number of electron it is 1. So now it is a 3-dimensional, that is species. So 3 coordinate axis. So from this now to frame the equation, wave function psi equal to this and this. This are denoted as the radial wave function. This distance. Okay. This F and G denoted as the angle. This half, next half. So angular wave function. Children, now the psi symbol denoted as wave function. Okay, here amplitude of wave function, electron wave function, and psi square. This one wanted to pronounce as psi square. Probability density. Okay, so now that is we find out the shape of orbital. That is 2 ways draw the graph. First graph, that is psi. Okay, psi versus r. And second one, draw the graph between psi square versus r. Are you clear, children? So from this 2 graph, why we are, that is draw this another one. This one for oneness orbital. Okay, so psi versus r graph, we cannot get the clear idea about the probability density. Okay, so probability density means that is the electron that is revolve around the nucleus. So how much that is electron density we are talking about. So if this psi square versus r, x-axis, y-axis, x-axis r, y-axis wave function. For second graph, x-axis r, y-axis psi square. Okay, children. So psi, you know, amplitude of electron wave function, and psi square probability density. These are denoted, that is electron is revolve around the nucleus. Okay, so now to measure the distance. Now to find out the distance that is of electron as well as nucleus. So from this nucleus, now the electron it is present, because electron is not only for this orbit, the second orbit also, this one for 1s orbit. So second one 2s orbit, electron it is present. So now to measure this distance, here that is denoted as, that is R. Are you clear, children? Okay, for 1s mean now to find out the distance, 2s mean to find out the distance. So R denoted the distance from the nucleus to, that is electron, that means outermost electron. Okay, depending upon the place, whether it is 1s or 2s or 3s. Not only to measure 1s, it measure 2s orbital, 3s orbital and 4s orbitals. Okay, so this first graph, it is not clear idea about this. Okay, so the second graph, that is psi square versus R, give the clear idea about 1s. So what is clear idea, now we are going to see. Before that, the psi square, here that is the two various, that is the properties. One is radial and another one is psi square probability density. Okay, so it varies with the, that is the two ways. One is radial distribution probability and another one is angular distribution probability. Okay, so in radial distribution probability, to measure the distance, that means now nucleus, electron is revolve around this nucleus. Okay, so now to measure the distance, okay, from the nucleus as well as electron, so distance. So the psi square probability density, it varies with the radial distribution probability, and another one angular distribution, that means this one is the sphere in shape, not flat. So electron is present here or here, so wherever it is present. So now to measure that is the direction. Okay, angle. So angular distribution property. So psi square, it varies with, that is the two concept. One is the distance and another one is direction, because it is the sphere in shape. Okay, so now to measure the angle, so angular distribution, so to measure the direction. So it is one is radial distribution properties, probability, and another one is angular distribution probability. Now that is, I draw the graph. Okay, so using the graphical representation, talk about the shape. For now, for this session I am talk about only the s orbital only. So first drawing 1s as well as 2s orbitals. Okay, so see here I draw 4 graphs. So first one, the graph between this one x-axis, y-axis. So psi versus R for 1s orbital. Okay, and next one, 1s orbital psi square versus R. Okay, so why that is draw the two graph mean, from the first graph we cannot get a clear idea about the probability density of 1s electrons. Okay, so from this graph, now see here, this line here, that is 0. Okay, so that is same, that is line, it is coming, and next one to reaches this R. Okay, that is the amplitude. So here we can get the clear, that is the graph. So from this graph we come to the conclusion, that is the probability density, that is the electron density. So now from that is decreases. Okay, so now here, okay, so that is decreases. So and next one, that is at the same time, now this radius, that is increases, radius value increases. At a particular, that is the level, this radius value to reaches, that is 0. Okay, we can, that is understand from this graph, the point is the probability density, that is decreases. Okay, at the same time the radius that is increases. Are you clear, children? So now see this, that is the diagram, you can understand very clearly. So now center nucleus, here electron, so each dot is not represented this electron, it is the probability. Okay, so now electron is present here, or electron it is present, or electron present here. So that is maximum electron that is present, that is around this nucleus. Okay, but it not the fixed place, because it is the way in nature. Can you understand, children? Okay, so now here that is electron density, that is more. So now at the same time, now this here that is outer, so now here the electron that is very lesser. Okay, so now the distance that is increases. So this graph shows that is the distance, the radius, distance between that is nucleus as well as electron increases. Okay, so now at the same time the electron, that is the density, it decreases. So from this graph, okay, and see the 2s orbital, this one for amplitude of wave function versus that is the r. This graph probability density as well as r. So see this graph, now that is the probability, that is the density, it is decreases. At the same time now this r that is increases. Okay, so next here at a particular point it reaches that is the 0. Okay, again it increases. Okay, so next it decreases and reaches that is the 0. So that means now see this diagram, here center pass nucleus. Okay, so this one set of that is electron, that means this one for 1s orbitals. Okay, so next here have that is the some empty space. Are you clear, children? So this empty space it denoted as that is the node, N-O-D-E, or nodal surface. Okay, so next one, this one 2s orbital. So compare this, now that is the structure, the size that is increases. This one for 1s. Okay, so now near the nucleus, that is number of electron is more, that is the electron density is, that is the more. So now the distance increases, decreases, the distance increases. So now the probability finding electron that is decreased. Okay, so same way here, so nucleus, this one for 1s orbital, so electron it is closer to the nucleus. Okay, probability density is more. So now see here, okay, so it reaches the point here, so that is denoted as the nodal. So here that is the no electron. So next one, this one denoted as the 2s. So now that is increases. Okay, so at a particular point again it decreases. So here that is the no electron, that denoted as, so 1s orbital, here electron it is present. So next one no electron. So again that is electron density is present here. Okay, so why this gap is aqueous means, so here that is the electron repulsion is aqueous, because 1s electron it has contained electron, here 2s electron it is present. So electron repulsion takes place. So now to create the vacant space. Okay, so at the same time in 1s orbital, here electron negative charge, here nucleus positive charge. So attraction takes place. So here the probability that is of maximum electron it is present. Are you clear, children? Okay, so now see here, to calculate the nodal surface or nodes, have the formula n-1. If 2s orbital, now to find out the node. Okay, so now n is denoted as the principal quantum number, that is 2. So 2 minus 1, 1, 1. So in 2s orbital, how many nodes are present? Mean that is only 1. So this is the one node is present. For example, 3s orbital. Next, draw the 3s orbital. So 3s orbital, how many nodes are present? Mean now using the formula to find out the nodes. So n, the value is equal to 3. So 3 minus 1, that is 2. So in 3s orbital, 2 nodes are present. Children, once again, this graphical representation is very important in 1s orbital. Okay. So now, that is the probability, this one probability, that is a density decreases, at the same time the radius increases. Okay, so this 1s orbital, now in boundary structure we that is draw like this 1s orbital. So from this, now this one, it is like that is the sphere shape. So s orbital is sphere or spherical in shape. Okay, here nucleus is present. This one for 1s orbital. In 2s orbital, the boundary representation diagram, nucleus. Okay, so next one, this 1s orbital. So here that is have some gap, and next one, that is the second one. Okay, so this one for 2s orbital. So boundary, that is a boundary diagrammatical representation. Now, we got to continue the part. So this one sphere. Okay, so the first sphere distance r, the second one r plus dr. So now to consider the volume of the sphere, we know the formula 4 by 3 pi r cube. Okay, volume of the sphere. So now that is differentiate, that is volume. So dv by dr, differentiating with respect to r. Okay, this one studied in the maths class. Okay, differentiating part, this is the general formula d with respect to dr. Okay, so r power n equal to n r power n minus 1. So here that is 4 by 3 pi, that is the constant. Okay, 4 by 3 pi constant. Now differentiating, that is r cube only. Okay, so now this n equal to here 3. Okay, so now write n is equal to 3. So 3 r n minus 1. So 3 minus 1, that is 2. Okay, children. So this one studied the maths part. Okay, so now this 3 cancel. So what about the remaining? That is 4 pi r square. Okay, so dv by dr. So this dr is moving here. So now both sides multiplied with this psi square, probability density. So psi square dv equal to 4 pi r square psi square and dr. Okay, so this 4 pi r square psi square. See here some textbook given in the graph psi square versus r, and some textbook given here 4 pi r square and psi square. But in our textbook given in the diagram 4 pi r square psi square versus r. Okay. So from this is a 1s orbital graph. Okay. So from this graph we come to the conclusion this s orbital is the sphere, spherical in shape. We come to the conclusion. Okay. So now center, nucleus, electron is revolved. So now this electron, maybe if it is present here, now to measure the distance, that is the radial distribution of probability, that alone we study here. Okay, radial distribution. So that is the distance. So now see here from this graph, that is 0.5 and here. Okay, so that is the distance is 0.52 for 1s orbital. So this value is equal to Bohr radius. Already we studied in the Bohr theory also. Okay, radius of 1s orbital 0.52 angstrom. Okay, here the unit is that is angstrom, and some that is a unit that is nanometer also we use, but here we using it is angstrom. So 0.52. Are you clear children? So now study for this, that is the session, we concentrate the topic shape of orbitals. Shape. for S, P, D and F. Now I am taking only 1s and 2s children. Okay, so this one is explain me. Now talk about the wave function, that is psi. Okay, so next one, psi, that is the formula, that is r theta pi equal to, that is we frame one equation. Okay, that is capital R F, next G, we know the formula. Okay, so next one, that is two graph. One is amplitude and another one is probability. So this probability density. So here, that is we come to the conclusion, that is S orbital, that is sphere. So electron, it is wave character, so it present anywhere else. So now the density that is around this nucleus, that is more. Okay, so now in 2s and 3s, the size is that is large. Okay, compared to the 1s. So it depending upon the size is depending upon the principal quantum number. Okay, that is the n value. Are you clear, children? Okay, so next one, here, that is near the nucleus, that is electron is crowded due to, that is the force of attraction, because nucleus, that is negative charge. Here electron, sorry, here positive charge, here negative charge. So due to attraction, so crowding, that is electron. At the same time, it is not present in the particular place, it is present is anywhere else. Okay, so children, now come to the end of the session. So now for this session, we concentrate the shape of orbital, especially that is study the s orbital. In s orbital, we talk about only 1s and 2s. Okay, so 1s orbital, no node. 2s orbital, one node. This one node calculation, that is using the formula n-1. And next one, here the main theme for this, distance, that is decreases. Distance means from the nucleus and outermost electron. Distance decreases. Now the probability of that is finding electron, that is increases. So this one, this is the key point. Keep in your mind. So next one, this is orbital. It is spherical in shape. Children, I hope you understand this session. Thank you.